webinar today on 5G small cells for public works officials. My name is Renee Railsback, and I'm the president of the Colorado chapter of APWA, and I'll be your moderator for today's session. Unfortunately, we regret that we've had to cancel our chapter conference this year, but we've scheduled a couple of these webinar sessions in lieu of the conference. So keep a lookout for next month's session on November 20th with John Burke and Dave Zakutis on communication. Thank you for joining us. Today's presentation will cover a variety of points, including 5G as a revenue generator, post-pandemic needs for broadband, radiation health, and much more. As a reminder, our session is being recorded and will be posted on our APWA chapter website afterward. Initially, everyone will be muted. This is just a reminder that if you are not the speaker or are called upon, please remain muted throughout the session as to not disturb our presenters today. If you have any questions for our speakers during the presentation, please type those questions into the chat pod, probably down on the bottom of your screen. There will be a link for the chat pod. Post your questions in there and I'll keep an eye on it. And we'll be able to ask the presenters these questions at appropriate times throughout the program. Our speakers for today's session are Dave Zelenak and Ed Barrett. Dave is an internationally recognized civic innovator, speaker, and licensed civil engineer who founded the nation's first municipal innovation team focusing on emerging transportation and smart cities technologies. Dave has 30 years of senior management experience at the municipal, state, and federal levels, as well as consulting engineer managing the full spectrum of transportation service delivery and public works. He consults with public sector agencies and the private sector on smart cities technologies, innovation processes, transportation infrastructure, and public-private partnerships. Dave was an APWA Colorado chapter president in 2012, and he is now the manager of local government services for HR Green. Ed is vice president and practice leader for HR Green's fiber and broadband practice, overseeing all consulting and operation activities. He has led the analysis and strategic planning efforts for counties, municipalities, and special districts. His experience includes work in the telecommunications sector with more than 10 years of telecom and broadband services experience working with both carriers and local communities. His work has focused on the study of municipal broadband feasibility and the creation of innovative partnerships that link community and private sector 5G deployments. Ed has presented numerous webinars on municipal fiber and broadband strategies, and including presentations for the Alliance for Innovation and the various state and local professional and technical associations. Welcome, gentlemen. Thank you for joining us today. We look forward to your presentations. Dave, would you like to begin?
Yeah, Renee, thanks so much, and thanks to you, Renee, Pam, the APWA chapter, and I can't resist giving a shameless plug, excuse me, for Dan Hartman, who I see has also joined us this morning. Dan, as you may know, is the regional director on a national APWA level. So Dan, especially thanks to you for all the hard work you do for the not just the state chapter here, but also on a national level as a national member of the board of directors. So with that, Renee, yeah, so I'd like to talk briefly. Again, that's who we are. I'm Dave, and we have Ed Barrett, both of us with a consulting company called HR Green. I spent most of my career, like Dan, as a public service employee with the city of Centennial and the city of Colorado Springs here in Colorado. A public works director. I couldn't get the job down pat in either. So our presentation today will have really 5 parts. A little overview, where are we with small cells and 5G? Where are we? How did we get here? Small cells, what is a small cell? What can you do? Repurposing your infrastructure, can you monetize this? Is there a possibility for cost recovery? What's this all really worth? Part 4, we'll talk about small cells and arguably big health concerns, enforcing the FCC safety rules, and something you'll hear about called maximum permissible exposure, or MPE is the FCC term, to radiation. And then Ed will be our closer. and absolutely endlessly fascinate everyone with part 5, which is strategic initiatives, not just talking about small cells and a defensive strategy. That's kind of my part, but Ed will talk about really strategic initiatives, smart cities, and going on the offense. So that's kind of our 5-part presentation. Just a very brief overview of HR Green. The company is over 100 years old. We've got about approaching 600 different employees now, and Ed and I both work in our company's governmental services business line, but we also do water resources, land development, transportation. About 80% of our company is working with the local and state governments. So a brief overview of what we're talking about again today. Small cells, we'll talk a little bit about the RF compliance and plan review side of it. Small cell policy advisory and consulting, small cells and streetlights. You wouldn't think there's a connection, but we'll talk about those. Ed's really good at talking about small cells in converged networks and new developments. Talking about traffic signals and small cells and broadband conceptualization. On the fiber optic side, which is the backbone side, there's a lot going on with inventories, understanding what all cities and counties own in terms of their assets, looking at IGAs, intergovernmental agreements, partnering, looking at policies, broadband feasibility, fiber optic cable design, and something that's really emerging now, we're seeing a lot of, almost every day I hear something as fiber as a sensor. That's a pretty new topic, so bear with us there. Real quickly, what are others doing and why? There's a lot of cities and counties and state governments now working on things related to fiber, small cells, and broadband. And you may know that here in Colorado, just in the last few years, when I was with the city of Centennial as their public works director, we pushed through what turned out to be the second Senate Bill 152 exemption in the state of Colorado, and now there's over 100 more cities that have done that. What that means basically is that there was a state law passed about 15 years ago that said that it's illegal in Colorado to engage into any telecommunications partnerships. If you have fiber optic strands, for example, you can't flip those, sell them, you can't lease them, rent them to the public sector or to the private sector without a vote of the people. And so Longmont did the first vote of the people in Colorado state history back in 2011. I helped push through, as I said, the Centennial one back in 2013. And now there's over 100 cities that have placed ballot items successfully on their local ballots to exempt themselves. In other words, to allow their cities to do telecommunications partnering deals using city assets and maybe make some money off them. We'll talk about those a little bit here. So it sounds like a simple, stupid question, but what is broadband anyway? Real simply put, think of a 3 megabyte attachment. Oddly enough, the telecommunications people seldom work in megabytes, they work in megabits. And so broadband is defined really as if you can download if you have 25 megabit per second download capacity, that's about a 3 megabyte capacity. If you can download a 3 megabyte file in a second, loosely speaking, you've got broadband. If you can't download a 3 megabyte file in 1 second, you don't have broadband. And amazingly, in Colorado, almost half the people in Colorado typically, hard as it is to say, don't have broadband. And so 25 megabits download, 3 megabits upload is what the FCC defines today. And the numbers have changed. They will change in the future, I'm sure, but 25 and 3 is the FCC definition for broadband. You can go to, there's a lot of speedtest.net type sites to look up to see what your speed is. I'd encourage you as a homework assignment, give that a shot. Speedtest.net will tell you exactly what your upload and download speed is for free. How's broadband delivered? We won't spend a lot of time here, but obviously there's wireless and wireline. The wireless side, satellite and cellular, 4G, 5G, and other wireless services are out there. Wireline, DSL, which is the 100-plus-year-old copper wires. Coax cable is the 1970s, 1980s technology, and we like to say that the 5-star approach for delivering broadband is fiber optic cable. Many people use the term future-proof when it comes to fiber optic cables, and the important thing is that whether you're using a satellite connection, you're on a 4G connection, a DSL, it doesn't matter. Everybody uses a fiber backbone somewhere, and there really is no better technology today than fiber optic cables. What really matters in broadband, I've got 5 things up here, and I deliberately put speed as the last of the most important items, but latency, which means when you click your mouse, how fast does your system respond? Or if you're on a phone call, if you get that crazy, drives me nuts, that echo, hello, grandma, and then you got a half a second pause, that's latency. And so moving into 5G, a lot of that latency will disappear, at least practically speaking. But capacity, can the whole family be on at once? Do you have a good quality connection? I was just telling Renee and Pam that that was driving me nuts last week, that my wire line service was intermittent 3 days last week. I had no service at the house or my home office. So I had to drive to the physical office last week because the quality, the reliability of the connection was awful at my house last week. The lowest cost per bit, what does it cost you to get those megabits or megabytes? And then I put speed as the fifth of the 5 really important things here. By the way, everybody doesn't need all of these and different technologies, different costs, different benefits. We'll probably see all these technologies exist well into the next several decades or so. You'll hear the term gigabit, and the question is, what can you do with a gig? I'll kind of zip through some of these things. What I'd like to point out, though, is that there are a number of national studies done about home sale prices. And if you've got a fiber optic cable, and the cost, it varies based on where you're at and a lot of things, but a good rule of thumb to put a fiber optic cable into your home costs somebody between $1,000 and maybe $2,000, as high as $3,000 per house to install fiber optic cable. These national studies are saying that that people, home buyers, are more likely, millennials, think about it, they like to work from home, they've got a Zoom room, and to be effective in your Zoom room, if you have a fiber optic cable, your house on average may sell for about a 3% higher price. And so if you've got think about it, $1 million house, that's pretty expensive. A 3% increase means you get a $30,000 bump in your sale price, $30,000 bump in sale price for maybe a $1,000 to $3,000 investment. Of course, not everybody has $1 million house, but think about the cost benefit ratio of what's a fiber optic cable worth and what does it cost to put it in your house. We'll talk about fiber and the backbones and a lot of those things. Again, arguably not everybody needs a gigabit, which is 1,000 megabits per second today. But you'll be surprised in 10 years, we're talking about 10 gig lines. So part 2, we'll talk about small cells. Now we've talked about kind of the backbone and the technology a little bit. What is a small cell and what can you do about them, with them, for them? First off, let's talk about what the 4G network looks like today. There's a picture that I took. This is actually in Lancaster, Pennsylvania. I took this picture. It's just a cell tower on top of a large electric transmission tower. On average, these macro towers cost maybe $1 million on average. They'll transmit to your phone from 2 to 3 miles away. Again, just speaking averages, loosely speaking, about 200 phone connections per macro tower. And again, in megabits, which is the speed that these things live in, about 20 megabits per second is the typical speed that a 4G tower will put out there. Most coverage today, by the way, is either 3G. Most of it really is 4G or LTE, which is long-term evolutionary. I don't like the term. That's the industry term. It's just 4G souped up a little bit. And the point is here is that, that as 5G comes in, all this infrastructure will likely stay in place, and they'll just be adding 5G transmitters in many cases to the 4G towers, but that's not where the story ends by any means. Usually the way these things work, in this case here, if you look closely, this may have a fiber optic cable going up to the tower, or more likely, there's a point-to-point transmitter that brings a signal in, and then there's an omnidirectional or circular radiation pattern coming off the top of this macro tower. So that's the usual way. In fact, most of these macro towers don't have a fiber optic connection yet, and a lot of the carriers are working very hard, spending a lot of money, first getting fiber optic cables into their 4G towers so they can be 5G ready. Talk about 5G a little bit here. Fiber optic cables, really pretty much, if you have a 5G tower, you pretty much have to have a fiber optic cable into it. And we'll talk about the term, I don't like it, but it's a term in the industry called densification. The major carriers are densifying their network. And we'll talk about this, change from 3 miles to maybe as little as 300 feet in terms of spacing. And there's some new FCC mandates out there. Basically, what the FCC mandates are saying now is you can't say no. If you're a city, a county, a state agency, and the cellular companies want to come in and install stuff, you can define some aesthetics. There's been some lawsuits bouncing back and forth. We'll talk about those. But basically, you can't say no to an installer for a 5G tower. A little more talk about 5G. Again, not all 5G is created equal. Interestingly, different carriers have different thresholds, what they call 5G. One carrier in the US here calls their 5G 50 megabits per second. Another carrier says, no, that's BS. We're thinking our 5G is going to be 1,000 megabits or a gigabit per second. The carriers are defining 5G differently, and they're using vastly different frequency, and they have vastly different tower needs. Here in the US, if you're a geek, somewhere between 600 megahertz, where you get a lot less throughput in terms of ones and zeros, but you have a lot better range, is the lower end of 5G's frequency, and as high as 50,000 megahertz, that's 50 gigahertz, is the upper end of where 5G. That's a massive range in terms of frequencies or channels. And by the way, all these are still working with not just the FCC's rules and the federal laws, but the laws of physics really define how much you can get in terms of throughput based on the frequency. Here's one new slide I wanted to put in that was just published about 2 weeks ago, and it's kind of hard to read, so I apologize for this. But what this says, if you look closely on the far left there, it shows the current 4G speed in the US on average. If you have a 4G phone, you're getting about, on average across the country, 28.9 megabits per second in the US. And if you're on 4G, if you're on 5G and you're in the US, the average download speed is 50.9. And so the 1.8x box below that says that in the US, the difference between 4G speed and 5G speed on average is only about 1.8 times. So you go from 4G to 5G, and the speed increase is only 1.8 times in the US. Now go to the far right there, and you look at Saudi Arabia, they're also at exactly 28.9 megabits per second on 4G, but look at what the average 5G speed is in Saudi Arabia or South Korea. They're getting 14 times that. So I guess the point is here is that beware, be cautious. Some pictures of some small cells here. On the left is a photograph of actually looks like a pretty aesthetically pleasing small cell combination light pole and a little 5G small cell transmitter. Great idea, great location until you think about it. If you're stepping out on the balcony there, is there a radiation concern from people stepping out? You walk out with a cold cup of coffee, you might have a warm cup of coffee because of the radiation coming off there. It's very difficult to tell as a consumer or as a homeowner or as a balcony owner what the amount of radiation coming off that tower is. In the middle is a picture of downtown Denver. There's a 5G, looks like, again, a cigar tube looking, very pleasant 5G pole. But the question I would argue is might the government in this case had done something differently to include that 5G pole with the streetlights around it and reduce the aesthetic issue. And then likewise, there's a radiation issue, possibly based on how much radiation is coming off that to the second, third, fourth floor balcony owners in the downtown Denver one. Are they watching it? And we'll talk about RF energy and what that's all about. And then on the far right-hand side is a project I was involved with. This is off Dry Creek, just west of I-25, where we had one of the local telecoms pay for a full upgrade for a traffic signal mast arm combination with an integrated 4G transmitter in the mast of the traffic signal. Some other examples here. In the upper left corner, you can see there's a what's called a neutral host in the term. What can be done and what we're actually helping some cities with these days is bringing in fiber and power to pre-designated locations in cities. So for example, this is a Best Buy store with a fake cupola, and inside the cupola can be a number of small cell or large cell 4G, 5G transmitters, but they're pre-designed. And what the carriers love to see is when a city takes the initiative. City of Aspen, by the way, is a great example. We work with them. City of Aspen is working on these neutral hosted sites where you bring in, as I said, you bring in fiber optic cable and you bring in power, and then you can make those available aesthetically pleasing in the downtown historic Aspen district or wherever you'd like. You can kind of pre-position them. It does take a little bit of money and forethought, but that is one good way to control aesthetics. And then on the far right-hand side is a simulation of a project we did in Laguna Beach, California, with again an integrated, nothing really fancy there, but shows what can be done. Here's a picture of my neighborhood and some of the aesthetic controls. Again, thinking of aesthetic controls about above ground, below ground, or on the ground. Different rules control what happens where. If you're above ground, you can control those somewhat. On the ground, these are lightly controlled communications equipment just in our neighborhood in Cheyenne Mountain area of Colorado Springs, where there's a nice collection of boxes, and any given evening at 3 in the morning, one of these goes out. You've got a telecom truck at 3 in the morning getting into your neighborhood's boxes with power and other issues. Back to that Dry Creek signal one that we worked on some time ago. This is looking west toward the mountains, and I just wanted to call your attention to behind that that fence is a well hidden, we like to think, equipment box, which is integrated into the, again, the mast and the mast arm system. So the point is here is that you can take the offensive, you can be proactive in controlling your aesthetics. A picture here of some underground vaults and boxes, which are pretty invisible to the traveling public. Talking part 3 here, repurposing your infrastructure. Again, is there cost recovery? What's it worth? And let's talk a little bit about repurposing your stuff. Smart cities, there's a lot of action going on now with smart cities. I'll put a shameless plug in here for some work we did and what Breckenridge has done. Well, we've suggested that, that a lot of these smart city technologies that are out there right now, you can pretty much put sensors on your street lights and sensors on your traffic signals to pick up gunshots, look at license plates, read them, report them back. There's a lot of work going on. We'll talk about fiber as a sensor right now, control systems for utility systems. A lot's happening right now. Breckenridge has a great system now, where as you're pulling into Breckenridge, you can see what parking lots are open as a result of sensors and the systems they have. Really, what's behind all this is looking at, first you put the sensors out, and Ed will talk a little bit about the smart city layers of technology. But sensors lead to dashboards, and dashboards really, usually through the cloud now, lead to action. So you can direct people to things, away from things. You can engage with the public now through these smart city systems. I'll talk a little bit about streetlights and what's going on there. With smart streetlights, you can do, again, any sensor you can think of, you can probably pretty much hang on a streetlight. And I would tell you that, interestingly, using these streetlights as sensor platforms, that's the term that's often out there, is actually prohibited by most power companies. I won't name names in this presentation, but most power companies will probably tell you, no, sorry, if we own the pole, then you are prohibited from hanging stuff on there. And there's a lot of good reasons for that. It may not structurally be capable of handling excess loads. It may pull more power than you're paying for right now. And oh, by the way, excess revenue not only are the uses of these streetlights often prohibited by power companies, but the FCC defines the amount of revenue that an asset like that can generate for a city also is prohibited. Now, a city can generate, interestingly, a typical streetlight in Colorado, you're going to pay about 20 bucks a month. So $240 a year is pretty typical based on where you're at and what power company you're in. But about $240 per year in cost is what we're seeing across Colorado. Is pretty typical. Interestingly, the FCC has set the amount of revenue you can generate right at about $240 bucks a year for public infrastructure. So interestingly, if you're paying right now a power company, let's say $240 per year in terms of annual lease payments, you can generate roughly that much in revenue legally, according to FCC rules, on your public infrastructure. So one way of looking at it is you could say that if you structure your street lighting and your assets and you repurpose them thoughtfully, you can municipalize your lights. Again, I'll pick on Dan Hartman. City of Golden, I know, has done a lot of work. City of Greenwood Village and a number of cities across Colorado are looking at municipalizing their street lights. Often you need to at least bring up the topic of condemnation, because the street lights are seen not only as a cash cow by the power companies for the current revenue streams, but when they look in terms of in the future at 5G platforms and renting their existing assets to the local governments, not only is there current revenue streams, but there's future revenue streams that are really very valuable. And so the desirability for the power companies to turn these over to you is reducing. On the right's a picture I took of Vail, and Greg Hall, who's our colleague and friend and APWA past president, reminds me this is an older picture, I think this is about 3 years old, of a Vail streetlight. Vail owns now, I think, about 30 streetlights where they've included the fiber optic cable in many of them, and they've got transmitters that work collaboratively with the small cell, with the telecoms and the town of Vail. So these things are throwing out Wi-Fi signals. On the left is a picture I took of, I think that's in Riverside, California. The point is, though, is that the amount of power that's consumed by these streetlights often is about $1 or $2 per month in power costs, consumption costs, but you're paying $20 a month in monthly bills. So you pay 20 bucks for the rental of the streetlight, and only about $1 or $2 of that 20 goes to pay the power. And so again, a lot of cities are looking at changing or repurposing their streetlights from cost locations to revenue sources at about $240, $250 per year is what we're seeing is pretty typical. And so there's millions in cost savings possible. Interestingly, as valuable as the streetlight asset is itself, we often point out that when you repurpose your streetlights, you can argue that the conduit underground may be more valuable than the streetlight asset itself. Streetlight's very valuable, but think of it in terms of the conduit now. We were talking last week to some fiber installers here in Colorado Springs, and they were talking about the cost to put a linear foot of fiber in downtown Colorado Springs, could have knocked me over with a feather, is over $100 per linear foot. Look at the cost to put versus the cost of the condemnation action. There's a lot of money, not just in the value of the asset, but in the value of the fiber optic cable below there. So on those Vail streetlights, by the way, I was up there and just did a speed test on it myself. It's not throwing out broadband, so you don't get 25 megabits per second, but you are getting internet. So 4 megabits a second is what the speedtest.net speed check got coming off that tower there. Pretty good. It's free. It's Wi-Fi. And the telecoms like to see people get off their telecom networks, the cellular networks, and jump on, in this case, a publicly provided Wi-Fi network. It's not fast, but it works. I talked briefly about the fact there's a new technology now called fiber as a sensor. In fact, there's even a Fiber Optic Sensing Association, or FOSA, where the overall thought is that what you do now is that you can do hypergranular, that's a pretty cool term, sensing of, for example, pavement conditions, because on that fiber optic cable, not only are you pushing through ones and zeros, but you can measure very minute deflections in the cable. So for example, if there's a 20-ton cement truck that just went 62 miles an hour down longitudinally down over that fiber optic cable, the sensing technology will allow you to say, hey, something 20 tons is moving at 62 miles an hour northbound right over this fiber optic cable. And the sensing equipment's gotten a lot cheaper. And so what we're seeing now, cities are saying, hey, wait a minute, not only are those fiber optic cables valuable for interconnecting the public works yard with the school down the street, but you can also do traffic measurements and look at pavement conditions. There's no good way yet to do friction measurements off those fiber sensing cables, but there's a lot of money, a lot of time, a lot of interest being poured into fiber as a sensor, or fiber as a sensor itself. Talk briefly here about 5G and small cell deployment. This is a picture of the city of Thornton that we did, just looking at a network of what would a 5G deployed network actually look like in the city of Thornton. And this is a pretty typical neighborhood, so you have a little bit of warehouse, a little bit of open space, some apartments, some houses. That's why we just picked this particular location. And then at the time we did this a few weeks ago, there were 4 telecoms. You know, T-Mobile and Sprint have now merged from 2 companies, and they're merging into 1 company, and then Verizon and AT&T. So this still shows the 4 telecoms, the density there. But the point is that the densification that I talked about is coming your way, like it or not. Here's a graphic of a Connecticut city. This is a 1 square mile chunk of an actual Connecticut city, and they're showing in the density of the 4G towers in that Connecticut city runs about 7 towers per square mile. It's pretty typical for most cities. And so 7 macro sites. The first wave, which is what's being called low cell densification, will take the density from 7 per square mile to 27 per square mile. But wait, it gets better. Is it better 1? Is it better 2? The medium cell densification, I don't like the word, but that's in the lexicon, goes from 7 to 56. And if you liked or didn't like that one, check this one out here. The actual full high cell densification will take it from 7 per square mile to 109 at least in this one actual Connecticut city that they ran actual numbers on. 109 5G towers required per square mile. Wow, okay, so park that thought for a second. Talking about, so each of those towers has to have a fiber optic cable connecting to them. You can do it by open trench. Obviously, you can do it by saw cutting. A lot of talk now is about micro trenching, and some cities allow it. I know CDOT is now allowing it. I think they've got a 6 or 8 inch minimum, and then you cap over it. But when you look at what does it really take in terms of total dollars per linear foot, as I mentioned earlier, this is Laguna Beach, California. They were talking about, I thought $66 a foot was crazy until last week. One of my colleagues here said, no, Dave, downtown Colorado Springs, it's over $100 per linear foot. So you look at what's an open trench cost, what's a regular saw cut cost, a micro trench cost. The stuff is not cheap, but if you have these assets already in the ground, or you can get, for example, US DOT grant to allow you to interconnect your traffic signals with fiber, there may be excess capacity in your network, and that excess capacity is suddenly very, very valuable. So in terms of cost, it could be 100,000, maybe 300,000 per mile in terms of the value of those underground conduits and fiber optic cables. And in some cases, if you're lucky enough to piggyback on top of them, it may only cost you $2,000 to $4,000 to piggyback, and you get out of it maybe $100,000 to $300,000. Here's a picture of Centennial. I did not do the graphic, but this was done after I left the city of Centennial. This is Arapahoe Road looking to the west toward the mountains. And the graphic that the city staff did there shows, the densification to the city council. This is one of their graphics, what it might look like if they do nothing to regulate the aesthetics of that. The point here is that, that if a 5G permit drops into your city and you have no aesthetic rules, then you may be stuck with something like this. And this is one of the convincers, I would say, that convinces city councils, and many of you know, I know have already passed rules now that requiring telecoms to regulate highly what they're doing in your city. Here's a map, a screenshot I took some years ago when I was with the city of Centennial. Every green dot, red dot on the map there is a traffic signal in Centennial. And it showed in 2010, 10 years ago, there was virtually no fiber optic cable in there. We did impose some requirements saying, hey, if you are putting fiber optic cable in, we, the city of Centennial, reserve the right to do a co-location. And 4 years later, this is what the map looks like. So Centennial went really from just a couple miles of fiber optic cable to over 60 miles of the stuff. City put in about $600,000. Half of that was Dr. Cog money for traffic signal interconnect. So really, the city only put in about half the 600,000. The value, I've heard different numbers bouncing around, but the number I like the most is the value of this 60-mile network of conduits and fiber optic cables is 10 to 20 million. So the city put in 300 of their own and 300 Dr. Cog $1,000, and now have an asset worth maybe 10 to 20 million dollars. The slide I like the best, though, is a picture I took on Arapahoe Road right by the Shane Company, just east of I-25. There's a billboard. It says, hey, there's a company called Ting, you may have heard of, is now gigafying the city of Centennial, largely on the fiber optic network that was installed with this piggyback system. And so real quickly here, I'd like to move through and stay on time if we can. The way Centennial did it was the first pipe that goes in maybe 20 bucks, maybe now $100 per foot. But the cost to piggyback is about $2 per linear foot while the boring machine's out there, while the trenching is set up, and while all the permits are going through. And so the city was paying the upcharge at $2 and let the telecom or let somebody else pay the $20 per linear foot cost of that. And so really with that system, in which we had more time to go through the policies and the results, the point is that they've created a very valuable asset. For those of you up in Breckenridge, I'm not sure if our friends up there, James Phelps, also a former state chapter president, can tell you all about the Breckenridge fiber infrastructure. They've got a company now and an initiative called Fiber 9600. Of course, Breck is 9,600 feet above sea level, and they are really putting fiber optic cable. Here's a picture I took up by the post office in Breckenridge. The power company put in a new conduit and electrical cable, and then you can see just strapped there with some cheap plastic straps are bundles of plastic pipes for future fiber optic cable. And so here in Breckenridge, it's very expensive to dig a street up, but if somebody else is digging a street up and you can plop in a bundle of fiber optic conduits for future cable use, it's incredibly valuable. Again, 90% of the cost of these networks can be really in the pipe. not necessarily in the fiber itself. Here's kind of a weird thought. The cost and the value of these fiber optic cables and these underground conduits has gone just through the roof, to the point where now there's a new tactic that some are calling speculative conduit. In other words, if a trench is open, can anybody come in? Can a city come in? Obviously they can. Can others come in and add in conduit on a speculative basis? And so we're actually seeing a lot of policy questions now saying, hey, wait a minute now, why would we want a speculator to come in and lease out or rent out those conduits in the future when we, the city, could do that? And so there's a lot of policy questions and a lot of surprise, as you might imagine, going on with people saying, hey, we're a private contractor, we're a private entity, we want to install cables because we can and because they're very, very valuable. On the left there is just a picture of some conduits in a typical street setting. And again, the real key is to look at them now as a potential revenue source if and when possible. And then lastly, here's a real life, true life story about CDOT. This is looking up US 24 up into Ute Pass between Colorado Springs and Woodland Park. We did a deal last summer where we had a number of different players: City of Manitou Springs, El Paso County, Colorado Springs Utilities, not Colorado State University, Colorado Springs Utilities, and CDOT all worked together installing not one, but two conduits for 100,000 feet going up Ute Pass. What can you do? Can you retain control? Arguably, there's a lot of public policy that you can think about. This is a picture I took in Las Vegas, looking down from one of those pedestrian bridges. And I was astonished to see, holy cow, there's quite a cell tower there. I don't know what all is going on in that thing, but there's a lot of stuff happening there. And the question about RF emissions and infrastructure and policy really brings me to my part 4 of our 5-part presentation. Health concerns, talking about radiation and this max exposure to radiation that we're seeing here. Bottom line is that there's a lot of articles out there. You can believe any ones you want. I would say really, clearly the science is undecided. The FCC standard for radiation is more than 20 years old. In fact, I think it was mid-1990s. And there's a lot of countries. Belgium, I think, has the reputation now of being Europe's most strict country when it comes to radiation coming off those things. Here in the US, there's a lot of dialogue going on, and the FCC says you really can't deny somebody a 5G tower application on the basis of the radiation, as long as the radiation meets the FCC standards. And again, as I said earlier, the radiation coming off these things, what really is important with these things is how much power is, how many watts are coming off these things, what's the frequency, and how far away are them. On this one here, I wouldn't have much concern. This is it's far away, it's probably low power, and the frequency is probably just cellular. So in this case, I wouldn't worry much about the radiation danger off this one. It's high distance, it's probably low power, and it's within, I'm sure, the FCC standards. There's a lot of rules are coming out, and I wish we had more time to talk about these things. Basically, though, you can't say no if you're a community and you're being asked to put in being asked to allow a permit to come in for these things. There's a lot going on. Here's a picture from the Miami Herald newspaper. 5G is an absolute mess, somewhat, you could say, unregulated installation. That's got some work to do there. One term you've probably never heard, though, is called NIR reporting, N-I-E-R, or non-ionizing electromagnetic radiation. This is a picture I took of one cell tower site in suburban Denver that we were asked to look at and just evaluate in terms of the radiation coming off these things. The original permit came in to say, hey, we're going to put a 4G upgradable to 5G tower right along the street here, and it's going to have an omnidirectional and a line of sight backhaul, 700 watt transmitter coming off that, and it was going, we thought, precariously close to one house nearby, and an omnidirectional lower elevation 4G, probably again to be upgraded to 5G in the future. So it's both a high power and a low power system. Question I would ask is, is there a taking here? Because if there's radiation concerns at the ground level and you can calculate the max permissible exposure, or MPE, are you being denied the safe use of your property if there's RF radiation coming off that thing at a number that exceeds FCC standards? Is that a taking? Yeah, it's a policy question. So what we did in this case is we suggested, hey, let's move, how can you guys move this tower so this 700-watt beam is not going so close to the house? Move it somewhere else. And so they said, great, we'll move it over here. And we did a close look. Look in the trees there real carefully. What's kind of hard to see is now they're putting the beam through a children's play set not too far away. This is a picture of my house in Cheyenne Mountain area of Colorado Springs. I just used it to illustrate again the value when you look at streetlights as future 5G platforms. The number one problem we see really is there a topographic component to the radiation pattern coming off that thing? And that's my son's bedroom window right there. I'm not so sure if this streetlight by our house were to be proposed as a 5G site. I don't think I would want that without being able to peer into that NEAR report to make sure there's a PE credential behind the NEAR report, and to make sure that the MPE, the max permissible exposure, in fact is consistent with the FCC standards. There's a lot of questions. I guess the point is, if you're an approving agency, I would ask you to think hardly, ask for those NEAR reports, ask for a PE stamp on everything, and then look at and confirm exactly what's going on in terms of radiation from those. So, phew, Ed, I'm getting hoarse, and I think it's time, my friend, for you to take over and do the next final dozen or so slides. So there you go, going on the offensive.
Great, Dave. Thank you. I think that's a great summary of some of both the challenges and the opportunities for communities to, regain control over this confusing array of technologies and deployments, and in some cases what seem to be unstoppable forces. But I think, Dave, to your point, there are things that communities can do to play great defense, and thanks for going through those. I'd like to just spend a little bit of time on sort of if Dave has talked about some of the challenges and some of the problems and some of the opportunities, maybe a little more specifically, what are some of the best practices that we're seeing communities? So what can you do to help manage, number one, and finish up the defense conversation? But then number two, how can you also at the same time, not only manage, but leverage some of the opportunities that are created in this new fiber and broadband world to position your community well? So, step one, I won't go through all of this. Dave's talked about a large number of these, but, implementing effective small G 5G and small cell policies. So what are your standards? What are your attachment agreements? What are your aesthetic guidelines and design criteria? Having all of those things documented and accessible will create a much more workable environment with your provider partners and protect you against some of those FCC regulations. So I think we talked through most of this, and Dave, if you can swing to the next slide. So step two, Dave talked a little bit about the effort in Centennial, and we frequently will tell our clients that one of the most important things that you can do is look for opportunities to do what we call developing broadband currency. So as you try to figure out not only how do you play defense, but how do you leverage some of the opportunities here to execute your own city and own community goals, the development of broadband currency becomes tremendously important. So creating fiber-friendly policies, things like a co-location program where the city or the town or the village develops a formal program to put assets into the ground, frequently, as Dave mentioned, at sort of pennies on the dollar, and creating those infrastructure communication assets gives you a strong step up when it's time to raise your hand and go out and seek to expand your services internally, or alternately, and we'll talk a little bit more in a few minutes about creating partnerships with the private sector to accomplish those goals. A couple of just quick case studies. A client that we worked with here in Iowa, in West Des Moines, a suburban area for Des Moines, Iowa, really, number one, understood that there is a lot of connectivity between the issues Dave's talking about with small cells and the challenges of having deployed fiber in your right-of-way. West Des Moines was looking for a creative approach to solving kind of a key municipal problem. And Dave, if you go to the next slide, you can see an example of an urban arterial road that has been flagged for construction, and you know, very clearly you can kind of see if your goal was to deploy some fiber up this road, you're SOL at this point, because the right-of-way has already been completely chewed up. So the city worked with HR Green, and we recognized that there were some high-level goals that the city had. They did not want to be a broadband provider, but they did recognize how important broadband and accessible fiber is for the economic development work and that they want in their community. So their approach really was to, Dave, if you can just forward the slide, to create shared infrastructure. So that shared infrastructure, if you look to the right, we helped them to develop some innovative designs where we had large capacity duct banks. We had shared handhole farms for distribution to take this asset. And if you look at the capacity here, you'll see 12 4-inch ducts being deployed in about a 2.5 foot use of right-of-way. And in fact, if you took that same amount of infrastructure and tried to deploy it with 12 to 18-inch spacing, which is pretty typical, you would have probably been able to get only about half of that in the right-of-way, with the rest of the providers being unable to continue to deploy. So we applied this looking at both future and built infrastructure based on a goal of the city to get ahead of this. So as they're building future arterials and future interstate roadway, that the infrastructure is being built alongside of it to ensure that people don't have to come back after the fact and do additional street cuts and do, you know, tear up the pavement. And all of this really required a lot of active facilitation with the providers. So bringing them to the table, helping them understand the issues, and then ultimately helping the city of West Des Moines operationalize the system. And before we move off them, one thing that is very interesting is this work in and of itself to create this capacity was visible enough that Google Fiber came to the city and in fact offered their first new build in the last 4 years. So Google Fiber really pioneered a lot of the alternative development of broadband, came to West Des Moines and said, hey, you're doing some really cool creative stuff. If you'll agree to build the community-wide conduit network, we will agree to be your anchor tenant. We'll agree to help you fund a significant portion of it. And, you know, then we'll offer service ubiquitously across the community. Another example, a little closer to home, is a new development happening east of Aurora, Colorado, and just south of the airport, a large master plan community. And we were engaged to help them develop their technology plan. And you heard Dave, if you can go to the next slide, Dave, talk a little bit about a term that we call convergence. This is a master plan of the community, which ultimately will be about 12,000 homes with large commercial and medical. And the developer really did, because of the distance from downtown Denver, because of the mobility of people to work from home and work wherever in today's kind of post-COVID environment, you know, they wanted to aggressively have the technology hooks to make sure they could attract residents to the development. So our approach brought the developer together through an RFP process and essentially created a partnership in which there's a converged fiber optic network that's being deployed by one of the large national tower companies that includes leasing of that fiber for broadband communication, 5G enabled smart streetlights and smart poles, outdoor Wi-Fi, commercial distributed antenna systems for the commercial areas, all of that managed through a partnership. So, you know, one of the challenges with 5G is obviously that it is not a simple thing. It is an expensive thing to deploy. So communities may have to look creatively for partnerships to get those things done. Step 3, obviously, creating your strategy. So understanding where your policymakers want to take this issue. Are there comprehensive plan goals? Are there economic development priorities? How does it align with your smart city vision? Developing those goals becomes crucially important, because by the time providers have come in, deployed their asset, and moved on, you know, those opportunities to take advantage of those things happen very quickly. And if you sleep, if you don't have an aggressive plan put together, you will probably miss it, and the opportunities will be gone before you've really been able to leverage them. Lastly, partnering. Again, you know, partnership in this space, the deployment of technology that can be built once and used many times by both the providers and by the city, you know, really does give you an opportunity to get the gain you're looking for, while minimizing some of your challenges and some of your risks and some of your capital deployment. So we encourage you to look at this. We encourage you to look for ways to do this. This is an example in Aurora Highland that we just talked a little bit about, where there's a contribution by the developer of land and conduit infrastructure. The private sector partner provides an open access data center, fiber, smart poles, and there's actually revenue sharing that happens between that provider and the developer itself. So final thoughts, you know, again, looking for ways to play an effective defense. There is a wave of 5G that is coming ashore. I would argue that it's still building and it's not quite reached us yet. We're sort of seeing the first few waves now. So figuring out how to effectively play defense through policy initiatives, through near reporting, through those types of things, getting your asset management in place, creating broadband currency that can be leveraged, and effectively understanding your vision for fiber master planning, all become really essential building blocks in a strategy to address this really complex problem. And I think with that, we'd love to open it up with the last few minutes of the presentation to any questions that might have come in. Hopefully age appropriate and publicly appropriate comments, and we can avoid the remainder of the questions out there.
Thank you, Dave and Ed, for your presentation. Yes, we'd like to welcome any questions in the chat pod. If you have them, please type your questions for our speakers today. While you're typing away, I would like to remind everyone to look out for next month's session on November 20th on communication. More details will follow. Also, check your inbox for recent information that was mailed out about the virtual blood and food drive being held by our APWA Young Professionals group. You could win fabulous prizes, so look for that email. We have had some requests about the PowerPoint slides being available. So consider that, speakers, and see if there's something you might be willing to share with us to post with the video afterward. But the video will be posted on the chapter website for access. I do have a question here. It says, what is the best method for a city to use to get rules and restrictions in place? What resources are available?
Ed, you want to talk about that?
Yeah, sure. You know, I think there are some good general guidelines that have been published by organizations like CML in Illinois. The Illinois Municipal League has published a great sort of how to adjust to the state small cell regulations. You know, I think those templates are probably a good starting point if you're looking for sort of a free and simple approach to getting some regulation in place. I think the other thing I would suggest is that if you really want to take advantage of opportunities to control aesthetics and other things, that you probably need to think about bringing in a partner we have, have done this work probably for 30 plus cities around the country. And these can be extensive to very simple projects, depending on the depth. I know Dave has worked with a couple of communities, including Aspen, where there were some organized concerns around health initiatives. And so that village or town needed to be very thorough in how it was addressing it and how it was planning a deployment of 5G and planning to manage it. Others are looking just for some templates to create some consistency. So I think, Levi, that question has a lot of answers, but I think there's some very straightforward and simple ones. If you want to go a little deeper, there are a lot of lessons learned that we'd be happy to help you define further. But we'll try to avoid making this a commercial for HR Green, although we're really good at it.
Thank you. We do have another question, and it says, my firm does engineering and inspections on cell towers for tower owners and carriers. What are ways to help cities do pole inspections and engineering on wood poles?
One thing I would mention is here in Colorado, most of the wood poles are not owned by the cities. The power companies tend to own the utility infrastructure. Now that's not the case. The fact the largest municipal full service utility in the nation is Colorado Springs City. So the Colorado Springs City Utilities is probably not only the state's largest, but one of the nation's largest owners of poles. But that's not typical. So you could engage, usually with the owners of the poles. But again, right now we're probably on the leading edge of this tidal wave, as I said earlier, this tsunami of 5G stuff, to where some power providers are just now realizing, wow, there's a cash cow in every streetlight there, and over my dead body will a city municipalize those streetlight poles, because it's current revenue, it's lost revenue, and there's future revenue coming at them. So really, to answer your question, the best answer is probably it's the owner of the pole, and probably 90% of the poles here in Colorado are going to be owned by the utility companies, of which there's I think 30 or so munis, as they're called, about 20 co-ops, and a handful of IOUs, investor-owned utilities. Really, it's approaching the pole owner. In the cases where those are being municipalized, I would approach the cities directly, but really there's only a handful of cities now that have done that.
Thank you. What is the best way to get an accurate inventory of all of the fiber currently in the ground owned by others within your right-of-way?
Ooh, Ed, I'm going to have you talk to that one. I can't wait to hear your answer.
Yeah.
That's a hot button for us, I'll tell you.
Yeah, that is. And one of the things, I'll use West Des Moines as again, a little bit of a case study. They did ask HR Green to help them to understand exactly that issue. So as part of that project, we created some ordinance and regulation for the community that identified the availability of right-of-way, and then had specific things that providers were required to do if they wanted to use it. So if we had highly congested right-of-way, 90% of the capacity was eaten up, the expectation of somebody deploying in that right-of-way was different than if it was a new road with 20% capacity eaten up. So as part of that, we actually had to go through an exercise to identify who had what assets in the ground. That process is complicated and terrible and time consuming. I don't think there's any other way to say it. We looked at just the arterial roadways in that suburban community of probably 25 to 30,000 residents. And we actually did that by creating both 811 requests in some cases for assets on some of the roadways, but because we had been meeting with the providers throughout the whole process and had them bought in most cases asked them to provide us with GIS files, to provide us with shape files, to provide us with CAD drawings and PDFs, and had to do a lot of estimating on that. So if you're looking for, centimeter grade accuracy, that's going to be a big lift. If you're looking for, I think there's 12 pipes in the right of way, you can probably get to that level, but it's a a pretty time-consuming path to get there because there are no publicly available maps, and in some cases, providers are pretty reluctant to let you know that information because they view it as competitive and proprietary.
Yeah, well, what I would also say, maybe just expand on Ed's point there a moment, is that the cities can really take a lot of steps to require details. You know, I can think of some cities in the tech center, for example, that absolutely insist that every inch of every infrastructure, regardless of who owns it, gets not only outlined to the city, but the city gets delivered a GIS file, a shape file, that they can drop into their asset management system. That's huge. Other cities say, you know, all we really care about is you're going to dig a hole over here, a bore pit, and you're going to dig a hole over there where the pipe's going to come out of the ground. You just come in, we'll give you a arguably subsidized or no cost, low cost permit, dig the hole in the street, patch it as best you could, and when you're done, okay, there'll be some pavement markings, and like Ed said, you can call the locators in the future to find out what it is, but they have no earthly idea what's going on. We were talking to one agency, in fact, just this past week, they said that, look, in Colorado Springs requires you to patch back, and they disincentivize and they encourage you to put the fiber in like the year or two before the street gets paved. That's huge. Well, Bloomington, Minnesota, I understood just this past week, says that, look, you can't even do a SUE, you know, a subsurface utility excavation. You can't do a SUE pothole without doing a curb-to-curb repaving just to locate a little 6-inch diameter pothole. You do curb-to-curb repaving apparently in Bloomington, Minnesota. I would never have guessed that, but I guess the point is that there's this massive range of requirements from almost nothing. Here's a free permit, go dig a hole in our street, to you're going to repave curb-to-curb for a 6-inch pothole and anything in between. So you're a city, you can pretty much set the rules and requirements. I would encourage you, though, I guess to Ed's point, have everybody tell you what they're putting in the street, and then you can even require them to give you an as-built, locate after the fact to confirm what they said they were going to do is in fact what they did do, and that drops for free into your GIS system. As Ed said, we and many firms can help you do asset management to that level. But yes, it's very valuable stuff, and we strongly encourage you to take the highest level that you can.
What are other cities doing, if anything, to confirm that carriers are adhering to historic requirements?
So that's a very good question. You know, historic requirements are interesting in many states. There are FCC regulations, and then the carriers have really been trying to promulgate state-by-state regulation. I think in Colorado, there is not a sort of state small cell law or small wireless facility law. In many states, those statutes do have protection for historic districts where you can maintain a different aesthetic requirement, but it does require you to ensure that you have a policy or ordinance in place that carves out that right. So what we would encourage you to do is to make sure that you have written and adopted some sort of aesthetic guidelines that govern the deployment of small cells in your historic districts. You saw Dave put up what we like to call our best bad examples, where people are lashing stuff to trees, and you know, it's not usually that bad, but we understand. I mean, if you're in Dan in Golden, and your gateway monument, you know, has small cell transmitters strapped near it, you know, you're sort of ruining the visual gateway to your community, and those things become very important. And we would strongly encourage you to create some aesthetic guidelines that you publish and make available, because once you've done that, the carriers are required to address those. And you know, we encourage our communities probably to reach a little into what is some gray area with FCC regulation being challenged in court. We encourage you to probably overreach a little, because you can always give ground on this, but it's hard to take ground if you've set the boundary or haven't set a line in the sand for the carriers to respect.
Thank you. You did mention Dan and Golden, and he did mention as an FYI, that Golden did purchase all the lights and poles from Excel, but it took them about 7 years. They're now looking at upgrading all the poles to allow for 5G and smart city use. And they're building a fiber backbone to tie most areas together. So if any of you have any questions on that process, maybe Dan Hartman can be a good contact for you there at Golden. We do have another question. If a carrier wants to install a small cell on an Excel-owned light pole, can Excel say no?
Ooh, you know, that's a great question. In fact, that is kind of the latest generation okay, let's municipalize the pole. And now some cities, this is going on in the Northeast, where some cities are saying, look, we, the city of, and then you insert a Massachusetts or Connecticut town, we're going to municipalize the pole and use our public authority, if needed, to condemn the poles and take them from the power companies. But then, remember I was talking about, there's about, a city can charge a little over $200 per pole per year as renting it as a 5G platform. What they're doing then is they're municipalizing the poles, and then they're flipping them, giving the ownership of the pole from the city then to a private owner. And what that does, I guess, to your question, so Excel is a private owner, they're an investor-owned utility. They can charge whatever they want, to whatever they can get away with, and whatever they think is reasonable becomes their pole charge. Now there are some PUC regulations and tariffs and things that apply to the power component of that. But essentially, if you're a private owner, and Excel arguably is an investor, it's a private corporation, you're a private owner, you can charge whatever the market will bear. And so basically, yes, Excel can say no, because they are the private owners of those poles, and they can charge whatever they want. I would love to hear from others out there who can shed some light there. But yeah, from what I'm seeing, there's this kind of now this new generation of, you take it from the power company, the municipality takes it over, and then they flip it to a private sector. And then part of the revenue stream then flows back to the city, because the city then gave these assets, this 1,000 or 7,000 streetlights, to this private company, and they get a little piece of the action, a little revenue return for the time and effort it took to do that. So there's a lot of really cutting edge ideas. But yeah, your question there about the Excel poll, Excel, as far as I understand, they can say no. They often, by the way, do say no, because they'll do a structural analysis, and if the structural numbers in Colorado won't support, literally won't support the supporting of a 5G tower, my understanding is they can say no. Some states in the country are required to upgrade the pole. If you're a city, and if I heard it right, Florida is one of those. If you're a city-owned owner of a pole, you may be required at city expense to upgrade it to accommodate their stuff. I don't know that I believe that, but I've heard that that's the extreme example across the country. So great question.
Yeah. Dave, the other comment I'd make on that is we have seen carriers across the country, the investor-owned utilities, most notably ComEd in the Chicagoland area, start to just give blanket no's because it's not a publicly owned asset in the right-of-way. It doesn't fall under the FCC guidelines and requirements. So where a city-owned streetlight would fall under this, an investor-owned utility pole may not. So in Chicago, I know ComEd has started declining any and made it very clear to all of the cellular carriers and the tower companies that thou shalt not attach to our poles, which has the net effect of pushing them off the wooden power poles and looking for places to attach, which most notably become the city streetlights, traffic signals, other sort of raised structures. So, you know, as utilities begin to push that off their poles, I think cities are going to get even more requests to attach to city-owned infrastructure.
Yeah.
Is there a maximum a municipality can charge for macro sites?
Oh, a great question. Oh, it looks like that's from Jay. Hi, Jay. A great question, Jay. It depends. The best example I'll share with you is, think of the city of Aspen. Aspen asked that exact question, and there's a main park at the base of the gondola area, if you know Aspen a little bit. So if a city-owned park is involved, technically that's not right of way. It's city property. So I guess, Jay, to your question, it depends. If it's city right of way, if it's a street somewhere, you probably can't say no. And then you fall under the FCC rules. If it's not city right of way, if it's a city park, for example, city open space, the different set of rules kick in. But basically, the FCC really doesn't distinguish much between them. If based on federal law, a macro site goes by kind of many of the same rules. Small cells have slightly different rules, but it really depends more. The question is it in the right of way or on city property? And then really, if it's on city property, I don't think there's any. Ed, is there any limit on the amount if it's on city, like a city park, what you can charge versus city right of way?
Yeah, Dave, I in all honesty, when it relates to macro sites, we haven't done a lot of macro site consulting. You know, most of the work that we've done with communities has been managing this sort of wave of you know, small cell, you know, local service, filling in holes and gaps coverage. I'm not sure what the federal regulations or state regulations are on macro cells, because most of our work has probably fallen into the small wireless facility consulting side versus macro towers. So I wish I had a great answer. I'd rather say I don't know than fake one.
Yeah. Thank you. Are there any other final questions from anyone out there? We've reached the end of our list unless there's any others. Do either of our speakers have any final thoughts for the group as we close out?
Happy to help answer questions. You're free to call Ed or I. Our contact information is in the PowerPoint, or you can just get through Renee or through Pam to get to us. Happy to help, answer any question, and assist any way we can. Ed?
Renee, thanks for a webinar that didn't follow the normal script. It's always
I like to make things exciting.
So thanks for keeping us on our toes and for the invitation. We really do appreciate the opportunity to help communities try to figure out this sometimes confusing web of technologies and regulations. So happy to have the opportunity to speak to the members, and hopefully we've added some value. Thanks.
Yes, thank you very much for your time, gentlemen, today. I'd also like to thank Pam Weimer, our APWA administrator, for all her help behind the scenes and pulling this event together today. I appreciate her help. Thank you, everyone, for joining us today. We'll see you next month for our next topic. Enjoy your fall and Halloween.
All right, thank you.